Today in algebra, we're looking at cumulative test 11A. If you're following along, Mr. Shane's going to walk through how you would go about attacking each one of these problems and then have you at home apply that mathematical skill to calculate and complete each problem. Number one, Ron is renting a car for 5 days. He can spend $200 at most. There's a deposit fee of $50. What can he spend at most on the day the rental for the fee? You're going to see that 5 days is going to be multiplied by a certain amount plus $50 to get to a at most total of $200. So we have to spend less than $200. So in this blank here, you're going to have 200 because that's the greatest value. So our number has to be less than that. So I pointed to the left. Because you're taking that 5 days and you're multiplying it, you're going to then have $50 here and 5 times what by that $200. In order to find what that value is going to be, you would subtract from 200. 50 minus 200 is going to give you 150, and you've got 5 days. So you take 150 and you divide by 5. That's going to give you $30 per day. So your maximum fee per day is $30. That would give you to that 200 mark. Number two, the box and whisker plot shows scores of a basketball team. Use the interquartile range to identify outliers. Remember the IQR, the interquartile range is this value, Q3, subtracted from this value, and then you're going to look to see if there's a value that extends beyond what we consider the outlier range and beyond what we consider the outlier range for a number that's too big or too small. Well, Q3 here is 80 and Q1 right here is 60, so you subtract those to find the IQR, which is 20. So there's a 20 range here. Now you take 1.5 multiplied by that IQR to see if that number is larger than, and 1.5 times 20 smaller than that actual value to see if there's an outlier. 20 times 1.5 is 30, and if you go beyond that to 30 beyond here, there's no numbers that are outliers here, and 30 beyond this number, there's no outliers here, so we would say no outliers. Number three, simplify 2x squared, divide by 8x if possible, identify and exclude values. First thing we're going to do is factor out the greatest common factor, so we're going to take the numerator and write it out in prime factorization, and the denominator and write that out in prime factorization. And then we're going to factor out what is common in each portion. So I've got a 2 and a 2 that's common in each portion. I've got an x and an x that's common in each portion. And if I pull that out, what's left would be x over 2 times 2, which would be x over 4. The common factor that's coming out is a 2x on the top and a 2x on the bottom. And if you'd write that out like this, guess what? Those two things would cancel each other, right? So you'd be left with x over 4. The excluded value then is because there's an x here in the denominator, you can't have x equal to 0. Number 4, the following data shows scores for a math test. Identify any outliers. What's the effect of any outliers on the measure of central tendency? Here's your scores: 69, 75, 68, 98, 65, 72, 83, 70, 71. It looks like, obviously, 98 would be our potential outlier. Now, to go and check if it is an outlier, you would have to find what would be this set of data in a number from least to greatest, and then you're going to find the different quartiles of that set of data, and then you have to use what we used in this example to find that interquartile range, multiply by 1.5 to see if it is greater than that. In this case, that number is well outside of what would be the common range for our measures of central tendency. So when you have a number that's way too big, what does it do to the mean and the median? It bumps everything up. So the measures of central tendency would be higher with 98 included. So the measure of central tendency would be higher with that outlier included. They'd be lower if that outlier wasn't there. The overall average, the mean would be less, and the median would probably bump down because you don't have that number that's on that side of the scale. Number 5, simplify the expression 2x to the third y in the cubed exponent here. This is going to apply like our distributive property to the inside. So 2 to the third power, 2 times 2 times 2 is 8. X to the third is going to be our power of a power, so you take 3 times 3 and multiply it. That's going to give you x to the 9th, and y has a 1 over the top of it, so y times 1 times 3 is going to give you y to the third. Number 6, simplify the expression 2x to the third plus 3y squared plus 4xy squared minus 3x to the third minus 2x to the third y squared. In this case, we have to identify if we have any like terms, and then we can rearrange those like terms and use the common operation of addition or subtraction to simplify those like terms. So here I've got x to the third, and here I've got x to the third. Here I've got 4x to the third y squared, and here I've got negative 2x to the third y squared. I don't have anything that matches up with my 3y squared, so let's take a look at combining these two and then combining these two based on the operations that are in front of them. You've got a positive 2x and you've got a negative 3 here. So 2 minus 3 is going to give you negative 1x to the third plus 3y squared, because there isn't any math to do with that number. And then you're going to have positive 4x to the third y squared minus 2x to the third y squared. 4 minus 2 is going to give you positive 2x to the third y squared. Number 7, you're going to use your distributive property to multiply what's on the outside by what's on the inside. So you multiply here and you multiply here. What I like to do in this case is just rewrite that so it looks like that multiplication happens twice, and then I can put these pieces together, and simplify. In this example, you'd have x to the third y squared over x squared y, and now those are immediately going to cancel each other because we've got 3 minus 2 and 2 minus 1, so that you would be left with 3 minus 2 is 1x and 2 minus 1 is 1y, and those are going to be in the numerator. So that's my final answer for that very first term. The second term then is this put together, which we'll put over here, 2y to the third x to the third over xy. Now I'll do that same type of subtraction. 3 minus 1 is going to be 2, and 3 minus 1 is going to be 2, so you would have 2x squared y squared. Number 8, simplify the expression. 1 over n to the negative fifth. Anything that is negative in the denominator is going to be positive in the numerator, so that is n to the fifth. Number 9, write the polynomial 3y squared plus y cubed in standard form. Standard form says write the highest degree first. So here you've got y to the third, that's the third degree, and y to the second is the second degree. So you'd have plus 3y squared. The leading coefficient is the number that's in front of here. You can assume that that's a 1. That's what we would put there. Number 10, determine the slope of the line that contains the points 3, 7 and negative 2, 3. Here I'm going to put it into this format, but I use my little chart to set this up. 3, 7 and negative 2, 3. This is my x's and these are my y's, right? And then I'm going to number these. These are my 1s and these are my 2s. So I rewrite in this form from this chart. This is y2, this is y1. So I would have 3 minus 7, and then I would have negative 2 minus 3, and I can create that math. 3 minus 7 is going to give me negative 4. Negative 2 minus 3, same sign sum, is going to give me negative 5. Two negatives make a positive, so that's positive 4 fifths. Flip it over. Keep cranking. Number 11, tell whether the ordered pair 2, 4 is a solution to the system of equations below. X minus 2y equals negative 6, and 3x plus 2y equals 12. So it asks us to substitute the 2 and the 4 into both equations. So let's do so. The x would go here, that's a 2. The y would go here, that's a 4. Let's do the math. 2 times 4 is 8. 2 minus 8 is negative 6. Check, that makes sense. Plug in the next one. This would be a 2, this would be a 4. So you've got 3 times 2, which equals 6. You've got 2 times 4, which equals 8. And in this example, 3 plus 2 is 6. 2 times 4 is 8. 6 plus 8 does not equal 12. 6 plus 8 is going to give me 14. So here's what that would look like. 14 equals 12. That does not work. So we would say this is not a solution. Number 12, write the equation of the graphed line in slope-intercept form. Here you've got a line that's graphed. From that line you can pick out 2 points. From that 2 points you can pick out the slope. In this example you can also pick out the y-intercept. The y-intercept is right here at 1. So I know that my equation would be y equals mx plus b. That plus b would be positive 1. Now that point here is 0, 1. And this point here looks like it's at 1, 2, 0. So I've got 2 points. From those 2 points I can find my slope, right? It looks like it actually goes down 1 over 2, and if it goes down 1 that's negative, and over 2 would be 1/2. So here's my slope just from the equation portion, or sorry, the graph portion of this. I don't even have to use the slope calculation for that. I can just find what that slope is by finding the rise and the run, because it's going down in that leftward direction from left to right. It's a negative slope. Number 13, A shipping carton in the shape of a cube has a volume of 64 cubic feet. What's the side length of the carton? So to draw a cube, you draw two little squares like this, and then you connect all those lines just for a visual. It says if the volume is 64 cubic feet, that means this number times this number times this number, the length, the width times height are all the exact same. So you would take this value of what is to the third power, and then you would do the opposite of that. So instead of multiplying by the exponent to the third, you can actually take the third root of that number. So 64 to the cube root, which you're going to think, okay, what times what equals 64. If I just use my math, I know that 8 times 8 equals 64. So it's got to be less than 8. My other number is 2 times 2 times 2 is 8, so it's got to be more than 2. 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. 4 times 4 is 16 times 4 is 64. If I use some of those just basic math facts, put those together, I can come to that understanding. The better I get at that, the more easily I'll be able to identify some of those things with my number sense. So that is 4 feet. This would be 4 times 4 times 4. Number 14, you've got 3/5 equals x plus 2. You cross multiply, divide. Here's what that would look like. 3 times 15 is going to give you 45 on this side, and then you'd have 5 times x plus 2, so you distribute. 5 times x equals 5x. 5 times 2 is 10. And now I can use two-step algebraic expression to simplify. I would minus 10 minus 10. That's going to become 35 equals 5x divided by 5 divided by 5. 35 divided by 5 is going to give me x equals 7. Number 15. Solve 15 plus 10x equals negative 5 minus 2x minus 3 in parentheses. Now here you've got parentheses on the outside, so you have to distribute and multiply to rewrite that portion of the expression. Negative 5 times negative 2 is going to give you a positive 10x, and negative 5 times negative 3 is going to give you a positive 15. Now we've got to stop right here. If you notice, you've got 10x on this side and 10x on this side. You've got positive 15 on this side and positive 15 on this side. So no matter what I plug in for x, both sides are going to be exactly the same. Therefore, I have what's called an infinite number of solutions. X could equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I could go on, right? 16. So 7 equals negative 5m minus 3. In this example, we're solving for m. We need to get m by itself, so we're going to use our opposite operations. I would add 3 to this side, I would add 3 to this side, and I would get a new expression that looks like this. 7 plus 3 is 10 equals negative 5m. To get m by itself, I would do the opposite. This is a multiplication, so I'm going to divide by negative 5. That would cancel. If I do something on one side, I have to do it to the other side. Divide by negative 5. 10 divided by negative 5 is going to give me negative 2. In number 17, you've got a frame store purchasing frames for $12 each and then mark up the price by 45%. What is the new markup for that price? Two ways you could do it. Here's the value in which you would find the markup and then add it to the original value, or you can use the shortcut that Mr. Shane showed you. So you take that $12, you multiply by the percentage as a decimal, so 0.45, or you do the 1.45 method, so you throw that 100% in there already, then the included interest, that'll give you the end result right away. In this way that it sets it up, it says multiply by 0.45, find out what that value is, then take that value and add it to 12 to find your final value. In this case, if you take 12 times 1.45, you get a total of 17.4 as my final answer when I multiply these two. If I go back to do it the original way just to check my answer, 12 times 0.45 is 5.4, $5.40. If I add $5.40 for the markup price of the original price, 12 plus 5 is 17, and 40 cents gives me my final value. So both methods will give you the same answer. This just gives you that little shortcut to use and multiply by 1.45%. Number 18. Water flows into a swimming pool at a constant speed as shown in the table below. What is the rate of change? You're saying, well, how much does it go up here? How much does it go up here? How much does it go up here? It looks like it's going up 3, up 3, up 3 every time. And here it goes from 12 to 24, up 12, up 12, and up 12. To find that rate, you're going to compare the increase here to here. Volume versus time in this case is going to be your change. So you would have 12 in your numerator and 3 in your denominator as it's going up. That's going to reduce to 4. Another way you could set that up is using your y2 minus y1 method, in which you would have, let's see right here, 24 minus 12 over 6 minus 3. 24 minus 12 is 12, 6 minus 3 is 3, and you reduce that again to equal 4. So rate of gain of 4 gallons per minute. Number 19. It says write in point slope form the equation of a line that has a slope of 3 and passes through the point 2, 8. We know that in our point slope form that this is going to be our x and this is going to be our y. Here is our slope that we need to put in, and then these are going to be the x and y values for those points. So each thing that is in this problem is given to us what needs to be filled into this diagram. We just simply need to know what that point slope form is. It says that it has a slope of 3. That goes in this blank right here. Now this is x minus x1 and y minus y1, so our x value goes in this location because that's the x value in our ordered pair, and our y value is this 8, so it goes in this location in our ordered pair. Last problem, number 20. Determine whether the sequence below is arithmetic sequence. Remember, it's an arithmetic sequence if it has a common difference. And we look at this, -7 to -3, the difference was +4. -3 to +1, +4. 1 to 5, +4. So our difference is 4. If we kept that sequence going, 5 plus 4 is 9. 9 plus 4 is 13. Thanks for following along. God's blessings on getting that complete for today.